Hey everyone, welcome back to the channel. Today we are building a machine learning model that could literally save lives by predicting heart disease using real medical data. We'll take this project end to end, exploring the data, handling common beginner mistakes, and building a clean, powerful pipeline that mimics what real data scientists use in production. So, this is more than just coding. We are learning to think like a data scientist, like what patterns are in the data, what features matter, and how do we make our model not just accurate but trustworthy. Whether you are building a portfolio, preparing for interviews, or just learning machine learning for the first time, you're in the right place. Let's dive in. So, you can find the dataset in the Kaggle, and it is named as UCI Heart Disease data. And this dataset represents the patient's data, where each record or each row represents the patient's detail, and the target variable is named as num, where it is a 0 if they have no heart disease, and 1, 2, 3 represents the status of the heart disease they are in. Let's get started. Now download this data and upload it in your Google Drive, and mount your Google Drive to the Google Colab, and then start importing with the libraries. So mount your Google Drive, load the data set, and print the head to know the data structure. The structure of the data, how it is dealing and what. So here is the target variable num, and we are converting the target variable into binary because we have 0, 1, 2, 3 and 4 as our target variables. We want to consider it to be 0 or 1, whether he's having a heart disease or no for now. So all the numbers that are greater than 0, 1, 2, 3 and 4 are considered to be 1, and 0 is left as 0. So 0 is with no heart disease, and 1 we are considering it there is an heart disease that is present. And coming to the EDA and the data cleaning, we always need to inspect our data set before modeling. We need to check, are there any missing values or duplicate rows, or the common the column types are correct or not, because these three matter a lot in real-time data. Because if you have a lot of duplicate rows, there is a waste of time or a redundancy that can happen while building a model, or clean data is really a crucial point while building a data science model. So right now the data seems to be clean with no missing values, no duplicates, and the columns like age and TALAC are already numeric. Like you can see that sometimes the age column might be in string format or an object format. Object format is fine, but if it is in a string format, then we can't do any numerical operations that we will be able to. So this is just printing the columns that are present in our data frame. And now let's go to the visual insights. The first outcome is we are plotting a graph that that with a count of patients with and without heart disease. So this data set, more people are having the heart disease, which is unusual, but it's okay for now. But in real world machine learning, we need to think about the class imbalance techniques. Now our target is age distribution. Looking at the age distribution graph, we can find that most patients fall between 40 and 60. This is a critical risk group for heart disease. This already tells us that age is going to be an important predictor that involves. And now this plot is for gender versus heart disease, and looking at the gender, we see that the heart disease is more frequent in the males in this data set. This could reflect sampling, but that's another clue our model can use. And now chest pain versus heart disease. Chest pain type is amazing. We see a sharp correlation between certain chest pain types and heart disease presence. This will definitely help our model. So asymptomatic has a higher type of chest pain, has a higher rate of heart disease that can occur, and the least is typical anagna. So this might not be bothered, but asymptotic has a higher chance of getting, heart pain. Most of the people or the patients in our data set are facing this. So this might be a good catch for our model to predict the target variable. Next, coming or moving on to the correlation matrix, we build this using the heat map, and this shows us which features are strongly correlated with the target. We can find that the chest pain type, maximum heart rate, that is TALH, are highly correlated with the, and ST depression are strong predictors. Things like fasting blood sugar, not very useful here. Like, yeah, for more details what each column means, you can visit the Kaggle. Like, see, ID is unique for each patient, age is age of the patient, sex is their gender, CP means the chest pain type. So the description of these columns are present in this Kaggle. You can find and observe or explore the data before building a model, or learn about the data more. Now converting these columns into so the sex here in this data set is present as male or female. Now we need to pass zeros or 1 to our model. Hence we are converting male to 1 and female to 0 for our understanding. So for this being done with the categorical variables or more, we do this using one-hot encoding. So where a lot of beginners hit bugs. Categorical features like TAL and chest pain contain strings or coded values. Models cannot work with the text, so we use one-hot encoding. This turns each category into a separate binary column like TAL reversible defect and CP typical enigma. Always remember, after one-hot encoding, you won't have a column named TAL anymore. Instead, you'll have TAL fixed, TAL normal, TAL, reversible defect, and if you try to access TAL, you will hit a key error. Avoid that, okay? So, next, splitting the data. We split the data into training and testing sets, 80% for training and 20% for testing. This simulates the real world scenarios where your model sees new patients it hasn't learned from. Always use a random seed to make it more reproducible. And that's the example. Now, the fun part is here, building a complete machine learning pipeline. What is a pipeline? It is a structured way to combine multiple steps. For example, imputer fills the missing values. We are using mean in this case. So we are first filling our missing values and then standardizing our features so that no single feature is dominating. And let's select, or which feature selection selects the best features that are most predictive columns. So here we have used k is equal to 10, which picks the top 10 most features which are most helpful in predicting. And model building, we are starting model building using logistic regression. And the benefit for using this pipeline is it's modular, clean, and reusable. You can plug in other models or steps later. So this is fitting our data, training data into our pipeline. If you skipped a step like one-hot encoding or imputation, here's what you'd see, like a value error that we cannot convert string to float, and asymptotic for asymptotic column. Value error like X contains null values. This is why pipelines are so powerful. They automate and safeguard your modeling process. We now test our model using a confusion matrix. Like, this calculates how many did we predict correctly. And a classification report gives us precision, recall, and F1 score. We also calculated our ROC AUC score, which is 0.82 or 0.83, which tells us how well the model is separating our classes. For this For a logistic regression like this on a clean dataset, the results are solid. Now let's wrap it up. We cleaned the data, visualized patterns, and explored insights. One-Hot encoded categorical features, built a fully modular and error-proof ML pipeline, trained and evaluated a real-world predictive model. Now, you have a project that's ready for your resume, your portfolio, and real world job scenario. Next steps, what you can try are you can try a random forest or an XGBoost model and also tune the hyperparameters using grid search CV, and could also try deploying this model using Streamlit or Flask. If you want a full web version, drop a comment below and I'll make that the next video. Thanks for watching, and if you have learned something today, give the video a like, subscribe for more beginner to pro level ML tutorials, and share this with a friend who is learning data science and machine learning. Stay curious, keep building, and I'll see you in the next one.